11s, let's do question 11. So question 11 says, the circle AS, so A, S, B, and K. So that circle with a center O, so that's our center, is given below. Furthermore, a semicircle is drawn. The semicircle has points A, O, B, T, and R. So that's a semicircle over there. And then they say P lies on AR. So P is on the line AR, okay? And then AOB, angle AOB is 140 degrees. So AOB, that angle over there is 140 degrees. Okay, so everything is given. And 11.1 says calculate the size of angle S. Okay, so to get the size of angle S, there's angle S. So angle S is on the circumference over there. So if you move down with this chord and you hit A, and you move down and you hit B. From A, you can go to O, and from B, you can also go to O. If you have a circle and the chords goes, so this is A and this is B, you see there's S. But A and B can also go to the center. Then angle at center is twice angle at the circumference. So the angle in the center is the bigger angle. So therefore, if the center is 140, then angle S is half of that. So I'm going to write 11.1. Angle S is therefore 70. Angle at center twice angle at circumference. Okay, remember, go put in the values that you worked out, eh? So that is 70 over there. 11.2 says, prove that AS is parallel to KB. So you have to prove that AS is parallel to KB. So here's KB over there. Okay, so to prove that lines are parallel, if you have two lines like this and you have to prove they are parallel, then it's either you prove this is equal to that, then you have alternating angles, or you prove that this is equal to that, then you have corresponding angles, or you prove that this plus this is 180, then you have co-interior angles. So we need to figure out, is there a way that we can prove that? So you see there's our two lines. I highlighted our two lines. And let's see if we can prove something. I'm going to try and see if this is 70. Can't I prove that this is also 70? If you highlight this, then you have corresponding angles. They will look like this, like that. Corresponding angles. So far this is 70, that's S. I want to show that B4 is also 70, because then I see corresponding angles and therefore this line is parallel to that line. So over here we have a cyclic quad. That is a cyclic quad. And we know the opposite angles of a cyclic quad are equal to 180. So if this is 70, then this angle here is 110. Opposite angles of a cyclic quad. Okay, let me write that down. So that was angle K1. So angle K1 plus angle S is 180. Opposite angles of a cyclic quad. So K1 plus 70 is 180. So K1 is 180 minus 70. K1 is 110. Okay, then K2, because this is angles on a straight line, K2 is 70. K2 is 70. Angles on a straight line. You could also do exterior angle of a cyclic quad. Remember, this is a cyclic quad. And if you extend this line, there's the exterior angle. So if this is 70, this is also 70. Okay, so that was another way to get that 70, But anyway, let's continue. So I need to get to B4. Remember, that's the plan. The plan is to get B4 to be 70. So to get B4, I see a little triangle over here. So can't I work out T1? So that angle over there. Is there a way to work out T1. Okay, I'm going to show you another cyclic quad. From there to there, circumference, circumference, back to this. Do you see? That is a cyclic quad. It touches the circumference at 4 places. Circumference, 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 circumference. That's of the semicircle. So that is also a cyclic quad. So if this angle is 140, then this angle is 40. Opposite angles of a cyclic quad. T1 is 40. Opposite angles of a cyclic quad, so this is 40. So okay, now I can go in this triangle over here. And I can work out what's B4, So angle B4 plus 40 plus 70 is 180. Angles in a triangle. So angle B4 is 180 minus 70 minus 40. Angle B4 is 70. So there angle B4 is 70. So now that angle B4 is 70, there I prove this. Therefore, this line is parallel to that line. So therefore, AS is parallel to KB. And you have to have your reason. We used corresponding angles are equal. Okay, so let's continue to the next question. But before we do that, remember we proved that AS is parallel to KB. So let's make those lines parallel now. Next question, 11.3 says, calculate the size of ATR. Angle A, T, R. Okay, so it's that angle over there. So we have to calculate the size of this whole angle over there. Angle ATR. And that is for 2 marks. Okay. So angle ATR, when you highlight that angle, let's see. Let's do it like that. From there to there, ATR. That angle is in a semicircle. So do you see that? Remember the semicircle? If I move from the circumference to anywhere in the circle like that, that angle is 90. Angle in a semicircle. So that's the answer to that question. This whole angle is 90. So angle ATR is 90. Angle in a semicircle. Okay, 11.4 says, prove that TP will be a tangent. So TP will be a tangent passing through the points BKT. If R is 80 and TR is equal to TP. Okay, so let's quickly put in R is 80. So angle R is 80. So it's this one over here. So that's given now. This angle is 80. And TR is equal to TP. So TR is equal to TP. Okay, so to prove a tangent to a circle, what I normally do is, I'm going to take it out. Then the circle is BKT. So the circle is B, K, and T. So here's TP. So this is T, this is P, and then this is B is here, K is there, and back to T. So we actually need to prove that. So this is P and T. We have to prove that this angle over here is the same as that. If they are the same, then TP is a tangent. Okay, so let's go look now. This angle over here, do you see there's TP? So I'm going to highlight this whole thing. So there's TP. There's our circle. So here is our circle. But our circle, see the circle as a triangle. So there we go. So we have to prove that TP is a tangent. So we need to prove that angle T2, so there's that angle, is equal to B4. Let's see if we can prove that. We know that B4 is 70. So we know this is 70 over there. So we need to see if we can make T2 also 70. So this angle over here, we must figure out a way to make that 70. So okay, I'm going to start with the information they gave me. They said angle R is 80. So if angle R is 80, angle P2 over here is also 80. Okay, so let's write that down. So angle, so 11.4. So angle P2 is also 80. Angles opposite equal side. Then we can work out angle T. Then we can work out angle T3 because this is a triangle. So do you see it? So angle T3 is 180 minus 80 minus 80. So angle T3 is 20. Angles in a triangle. So this is 20 over there. Okay. Now if angle T3 is 20 and the whole T2 and 3 together, remember we said this is 90, eh? Angle in a semicircle in the previous question. Then if this is 20, then T2 is 70. So therefore angle T2 is 70. Okay, and there we proved it. T2 is also 70. So therefore TP is a tangent. TP is a tangent because angle B4 is equal to angle T2. Both of them are 70. Reason, why is it a tangent? Converse of the tan chord theorem. And that's how you would prove a tangent, eh?